Second, the asteroid belt's relative proximity to Earth makes it accessible for future missions, and some asteroids are rich in valuable resources, such as rare earth metals and water. The idea of asteroid mining, once pure science fiction, is becoming a technological possibility, and Ceres, with its potential abundance of water, could become a refueling stop for future deep space missions. The role of Ceres in science fiction. In popular culture, Ceres and asteroids have inspired countless works of science fiction, from early tales of space exploration to modern series like The Expanse, where the asteroid belt is a crucial setting for humanity. This inspiration stems not only from its scientific value, but also from the idea of a space, Wild West, full of possibilities and dangers. The discovery of Ceres, in a way, initiated this strand of human imagination. NASA's Dawn mission, which arrived at Ceres in 2015, was a milestone in asteroid exploration. The spacecraft spent several years orbiting Ceres, mapping its surface, studying its composition, and searching for evidence of water ice. The high-resolution images Dawn sent back to Earth revealed a complex world, with isolated mountains, intriguing craters, and the famous Occator bright spots, which turned out to be salt deposits and evidence of water plumes. Imagine the Dawn mission team, decades after Piazzi, receiving detailed images of an object he had only seen as a point of light in his telescope. This is the very essence of scientific continuity and the evolution of communication and exploration. The discovery of Ceres also underscores the importance of international cooperation in science. The Sky Police was an example of how astronomers from different nations could work together toward a common goal. This tradition of cross-border collaboration remains a cornerstone of modern astronomy and space exploration, with projects like the International Space Station and the Large International Telescopes. Ceres' transition from planet to asteroid, and finally to dwarf planet, reflects the maturation of planetary science. This isn't a rigid hierarchy, but a deeper understanding of the diversity and complexity of our own solar system. Ceres, the first of its kind to be discovered, remains a fundamental object of study, a link between the large planets and the vast population of smaller bodies. The exploration of Ceres and other asteroids also prepares us for the future of human space exploration. If humanity ever colonizes space, asteroids could become essential resources and outposts. That small speck of light spotted by Piazzi in May 1801 will be one of humanity's future outposts. From dust to pixel, communication transforms Salfog. The discovery of Ceres predates the era of modern communication as we know it: radio, television, and the internet. Its history is intrinsically linked to the development of scientific communication and, by extension, to the emergence of technologies that would enable future asteroid exploration. Piazzi's ability to notify other astronomers, Gauss's ability to share his calculations, and von Zach's ability to confirm the discovery depended on the communication of the time. In the 19th century, communication was slow and based on letters, publications, and face-to-face meetings. The dissemination of knowledge was a gradual process. However, the need to share astronomical discoveries and verify observations drove the development of more efficient communication networks. Moving forward, the exploration of Ceres with the Dawn probe in 2015 would not have been possible without the revolution in communication that occurred in the 20th century. Communication, in all its forms, is the lifeblood of exploration. From Piazzi's humble letter to the terabytes of data transmitted by Dawn, it is the bridge that connects the human mind to the cosmos. The multifaceted legacy of Ceres and the asteroid futurite legacy of Ceres's discovery in 1801 is multifaceted and continues to expand. More than just the first asteroid, Ceres is a symbol of the constant evolution of our understanding of the solar system and the universe. First, it represents scientific humility. First called a planet, then an asteroid, and now a dwarf planet. Ceres teaches us that science is a continuous process of refinement and reclassification as new information is acquired. It's not about being right, but about striving for a more precise understanding. Second, Ceres and its asteroid siblings have become objects of immense interest, not only scientifically, but also economically and strategically. With the growing debate about mining asteroids for scarce resources on Earth, or to support future space colonies, asteroids, and Ceres in particular for its water, are taking on a new kind of value. What Piazzi saw as a point of light is now seen as a repository of resources for humanity's future in space. The discovery of Ceres was also a milestone in the development of astronomical tools and methods. Gauss's method for calculating orbits from limited data was a mathematical revolution with applications for beyond astronomy. And the continued improvement of telescopes, driven in part by the search for these small objects, has led to even greater discoveries. The future of Ceres and asteroids is bright. They will continue to be targets of research missions, perhaps even manned missions one day. Each new discovery about them helps us better understand the formation of our own planet and the possibility of life elsewhere in the solar system. Ceres, the first asteroid discovered in 1801, is much more than a space boulder. It is a testament to the power of observation, mathematics, persistence, and communication in unlocking the secrets of the universe. From a tiny speck of light in a telescope to a dwarf planet with the potential to harbor water and resources, Ceres continues to inspire us to look to the sky and dream of what more we can discover. We have reached the end of our cosmic journey, which has taken us from a modest telescope in 1801 to space probes exploring the cosmos. We have seen how the discovery of Ceres, the first asteroid, was not just a scientific discovery, but the beginning of a revolution in our understanding of the solar system. From a gap in the Titius-Bode law, Piazzi spotted a point of light, Gauss calculated its orbit, and generations of scientists have deepened our knowledge of these small worlds, which today are seen as cosmic time capsules and potential sources of resources for the future. The history of Ceres shows us that the universe is vast and full of surprises. It reinforces the importance of curiosity, persistence, and, above all, communication, so that today's discoveries become the foundation for tomorrow's explorations. It's a reminder that even the smallest observations can have gigantic impacts. If you were inspired by this journey through time and space, please like this video. This helps us continue exploring the great stories of science and technology for you. To not miss our next videos, subscribe to the channel and turn on the notification bell. And to continue your adventure in knowledge, click on the video now on the screen to discover another fascinating chapter of our history. Thank you so much for tuning in and traveling with us. Until the next discovery, tune into history, because today we're going to travel back in time to the threshold of a new chapter in our understanding of the universe. Prepare to unravel the fascinating story of the discovery of the first asteroid, Ceres, in 1801. This isn't just the saga of a piece of space rock. It's the beginning of a revolution in astronomy, the moment our view of the solar system changed forever, and a milestone that, though it seems distant, laid the foundation for space exploration and modern communication. We'll delve into curious details, captivating characters, and the science behind this dwarf planet that opened the doors to our cosmos, a sky with gaps, and the search for a lost planet Imogen, the turn of the 19th century. The solar system, as we knew it, consisted of 6 planets visible to the naked eye since ancient times: Mercury, Venus, Earth, Mars, Jupiter, and Saturn, plus the recently discovered Uranus, sighted by William Herschel in 1781. Astronomy was a flourishing science, with meticulous observers and talented mathematicians unraveling the secrets of celestial motions. However, there was a gap that puzzled astronomers. According to the Titius-Bode law, an empirical rule describing the distances of planets from the Sun, and which worked well for the known planets, there appeared to be a celestial body missing between the orbits of Mars and Jupiter. This law, while not a fundamental physical law, had predicted Uranus's distance with surprising accuracy, which gave further weight to the idea of a missing planet. Considered the astronomers of the time. They were like celestial detectives, their telescopes like giant magnifying glasses, scouring the night sky for clues. The idea of an unknown planet was one of the greatest thrills of astronomical research. This search wasn't just curiosity, it was a matter of completing the puzzle, the solar system. Beginning in 1787, a group of European astronomers known as the Celestial Police or Lilienthal Society formed with an ambitious goal to organize a systematic search for the lost planet. They divided the zodiac into 24 sections, assigning each to a different observer, in the hope that someone would finally find the elusive body. Leading this initiative was Franz Xaver von Zach, a German astronomer who coordinated the efforts of observatories across Europe. While the Celestial Police were organizing at an observatory on the island of Sicily, Italy, one man was about to make an accidental discovery that would change the course of astronomy. This man was Abbot Giuseppe Piazzi, Catholic priest, mathematician, and gifted astronomer. Piazzi was the director of the Palermo Observatory and was working on creating a star catalog, a monumental project that required precise and repeated observations of the sky. On the evening of January 1, 1801, Piazzi was observing the constellation Taurus. Following his cataloging routine, he noticed an object not on his star charts. At first, he thought it might be a new star. However, upon observing it again the following night, he realized something crucial. The object had moved relative to the background stars. This was undeniable proof that it was not a fixed star, but a body in the solar system. Piazzi continued to observe the object for several nights, carefully recording its position. He noted that the object had a slow retrograde motion, characteristic of a planet, or an object more distant than the stars. On January 24, 1801, Piazzi wrote a letter to fellow astronomers, including Barnaba, Oriani, and Johann Alert Bode, the man behind the Titius Bode law, announcing his discovery, but cautiously. He described it as a new moving star. He hesitated to call it a planet, as it was too small to be a giant like Jupiter or Saturn. The problem was that, soon after its discovery, the object moved behind the sun, making it impossible to observe. Without a sufficient number of observations, astronomers lacked the data to accurately calculate its orbit, and there was a risk that the new body would be lost again, the sun's glare. This was a major problem, as just a few weeks of data were not enough to predict where the object would be months later. And here comes another genius of the time, the young German mathematician Carl Friedrich Gauss. Gauss, only 24 at the time, was a prodigy and had already made significant contributions to mathematics. He learned of Piazzi's discovery and the problem of recalculating the object's orbit based on limited data. Gauss developed a revolutionary new method for calculating the orbits of celestial bodies from just 3 observations. Using this new method, he was able to accurately predict the object's future position. His genius saved Ceres from being lost. Thanks to Gauss's calculations, on December 31, 1801, almost a year after Piazzi's initial discovery, Franz Xaver von Zach and Heinrich Olbers, another member of the Celestial Police, managed to rediscover Ceres, exactly where Gauss had predicted. It was a triumph of mathematics and international scientific cooperation. Piazzi named the new celestial body Ceres Ferdinandia, in honor of the Roman goddess of agriculture Ceres and King Ferdinand IV of the Two Sicilies. Later, the Ferdinandia part was omitted. The discovery of Ceres filled the gap in the Titius Bode law, and was initially hailed as the discovery of the lost planet, a new world, but not a planet. The discovery of Ceres generated great excitement in the scientific community. Initially, Ceres was classified as the 8th planet in the solar system. However, the story didn't stop there. Just a year later, in 1802, Heinrich Olbers, the same man who helped rediscover Ceres, discovered another celestial body between Mars and Jupiter, Pallas. In 1804, Carl Harding discovered Juno, and in 1807, Olbers discovered Vesta, 4 planets discovered in such a short time, all in the same region of space. This raised a crucial question. Could these small bodies be fragments of a larger planet that had disintegrated? Heinrich Olbers, in particular, proposed the theory that these bodies were the remains of an exploded planet. As more and more bodies were discovered in this region, the idea that each of them was a planet became untenable. They were too small, too numerous, and behaved differently from known planets. The term asteroid, from the Greek asteroids, meaning star-like, was coined in 1802 by Sir William Herschel, the discoverer of Uranus. He called them this because, through the telescopes of the time, they appeared as points of light, similar to stars, without the visible disk of a planet. This new classification was a watershed moment. Ceres, Pallas, Juno, and Vesta were no longer considered planets and became the first members of a new category of celestial objects, asteroids. This region of space between Mars and Jupiter, where most of them were found, became the asteroid belt. The discovery of asteroids was not just a matter of reclassification. It expanded our understanding of the diversity of bodies in the solar system. Previously, we thought only of planets and comets. Now, we knew there was a vast population of smaller bodies, each with its own history and composition. The role of communication in discovery. The story of Ceres' discovery is also a story of scientific communication in the early 19th century. Piazzi, by sending letters to colleagues, ensured that his discovery was known. The importance of Gauss's calculations was quickly conveyed through scientific publications and correspondence. Although there was no radio or internet, networks of astronomers, scientific societies, and specialized journals ensured the dissemination of discoveries, albeit at a much slower pace than today. Imagine the excitement of an astronomer in London, reading Piazzi's letter or Gauss's predictions. Communication between these scientists, often through months of waiting for letters, was what drove progress. This network of correspondence was the internet of the time, essential for the verification, validation, and dissemination of knowledge. The discovery of Ceres and other asteroids led to an increase in telescope production and improved observation techniques. More and more astronomers dedicated themselves to mapping this new region of the solar system. The 19th century saw a boom in the study of asteroids, with hundreds of them being discovered and catalogued. The classification of Ceres as an asteroid and later as a dwarf planet demonstrates the dynamic nature of science. Our understanding of the universe is not static. It evolves as new discoveries and technologies allow us to observe and analyze the cosmos with greater precision. The history of Ceres is a perfect example of how science corrects and deepens over time. Ceres and the doors of space exploration. Discovery of Ceres and the asteroids opened a new horizon in the human imagination. The possibility of exploring not only the planets, but also these smaller bodies. Although physical space exploration was more than a century away in Piazzi's time, the discovery of the asteroids planted the seed of the idea that the solar system was much more vast and diverse than previously imagined. Asteroids, including Ceres, have become objects of fascination for several reasons. First, they are considered time capsules of the solar system, because many of them have not undergone major geological processes like the planets. They preserve primordial material from the time of the solar system's formation, some 4.5 billion years ago. Studying asteroids is like reading an ancient book about the origins of our own cosmic home.